In today's video, we are going to be graphing some exponential functions. This is just basically an extension of what we've already done so far. So I'm going to be recapping what you've done. We're going to graph a couple of functions by hand. There is some practice linked for you on our Brightspace. And then you are going to submit the function graphing exponential functions. All right, so what we know so far. So when I look at these graphs or these functions that I have here, the first one is f of x equals 2 to the power of x. So I know that this is an exponential function, and I know that it's just going to be like this, increasing. If I compare that equation to the next one, so g of x equals 8 to the power x, I know that this one is also an exponential function that's increasing, but since this base is 8 and that's bigger than this base of 2, I know that this g of x equals 8 to the power of x is steeper than the 2 to the x. Now this function h of x equals 3 times 2 to the x. This does change things. These types of functions are what we're going to be focusing on today. And so you're going to be able to see that this graph looks very similar to the first one, except it will have a different y-intercept. So again, this is what we're going to be focusing on today. In this last graph, j of x is equal to 1/8 to the power of x. We know that since this 1/8 is a number less than 1, this is going to be exponential, but it's going to be decreasing. All right, so we have an old graph, so f of x equals 2 to the x. I'm going to go ahead and fill this in for you. So just as an aside, I guess I'll do some of the work down here. If we have f of -2, that means that we're going to do 2 to the power of -2. Now, if we're thinking about these exponent rules, that means 1/2 to the positive 2. So this is equal to 1/4, or 0.25. Now I'm just going to fill in the rest for you. If I have 2 to the power of -1, it's going to be 0.5, 2 to the power of 0, 2 to the power of 1, and 2 to the power of 2. Now 2 to the power of 3 is 8. All right, so I'm going to go ahead and graph this. So I've went ahead and I've put all of these coordinates in there for you. I did have to zoom in, and it's still a little bit rough, but that's okay. It gives us a good idea of the shape and the steepness of this graph. Now, if you're on Desmos and you want to get a table of values, what you're going to do is you're going to start entering a new graph. So you'll type in this equation. So now's a good time to try. So if you type in y equals 2 to the power of x. So you hit shift and then 6. You see that little hat? That means exponent. And then you type in x. It will graph it for you. Now, once you are clicked on that graph, if you hit the settings wheel, it is the little cog, like it's a circle at the top, you will be able to click on a button that says convert to table. It looks like a table of values. That will graph a table for you. I'm going to go ahead and show you how to do this in class, but if not, please ask me for help. Now, once you have that graph or table of values, you would be able to plot them and connect them just like this. All right, so I've went ahead and I've done this table for you. This would be a great time for you to try this on Desmos, try and see if you can get these numbers. Now that I have this table, I can go ahead and start plotting these values. So -2 is at 0.11, -1 is at 0.33, 0 is at 1, 1 is at 3, 2 is at 9, and then I can't even graph 27 on here. So this one got so steep so fast. Notice how I fit all of the table from 2 to the power of x on this grid, and I can't fit it on this one. And again, that's because now we're graphing 3 to the power of x, so it is that much steeper. All right, so these are the new graphs that I said we're going to be talking about today. This graph is different than the previous graph because it has a 2 in front of it. Basically, what's happening with these numbers is that all of them are being multiplied by 2. So this changes, like the title says, our y-intercept. So I'm going to go ahead, I'm going to fill in this table of values, and then we'll plot it and you'll see what I mean. All right, so I filled in this table of values. If you remember what our last table of values was, great. You'll see that all of these numbers have been doubled. If not, what you can notice is that this first one was 0.11, then it was 0.33, then it was 1, then it was 3. So every single one of these has been multiplied by 2 because that's the number in front here. So I'm going to go ahead, I'm going to plot these numbers. I'm sorry, it's going to be a little bit rough. So at -2, it's at 0.22, then 0.66. Now normally all of these exponential functions we've graphed so far have had a y-intercept of 1. Now our y-intercept is 2. So remember, that y-intercept is the point on the graph that crosses this y-axis. Then I'm going to continue 1, 6, 2, 18. I can't even graph that. So this 2 in front has made this graph even steeper than it was. All right, I think it's time to take a look at one of our graphs here. So I see a 3 out front. I know automatically that's going to change my y-intercept. So instead of my y-intercept being 1, I know that it's going to be 3. Now, I see that this function here, this number here, is less than 1. That means that it's going to be a decreasing function. I can go ahead and I can get a table of values for this, so x and y, and that will help me plot this graph. So if I do -1, I'm going to get 3 times 1 over 2 to the power of -1, and that's going to give me 6. I know if I plug a 0 in, I get 3 because that's the y-intercept, but if I wanted to try, I could do 1/2 to the power of 0 and then times it by 3. If I plug in a 1, 1/2 to the power of 1 multiplied by 3. If I plug in a 2, 1/2 to the power of 2 multiplied by 3, that's going to give me 3/4 or 0.75. So if you think about what's happening to all of these numbers, they're dividing by 2 every single time. That's what tells us that it's decreasing the way it is. So -1 is all the way up at 6, then it went to 3, then it went to 1.5, and then it went to 0.5. So I can tell that my graph looks like that. All right, so this is where it gets fun. We are going to be writing an equation. So we know that our equation is going to look like this. It may or may not have a number out front. We're going to have a number in the brackets, and we know it's going to be to the exponent x because we know that it is an exponential function. So the first thing that I'm going to do is I'm going to look for my y-intercept. In this example, my y-intercept is 3. So I know that that's the number that goes out front right here. The next thing that I'm going to do is see how much this is increasing each time. So I know that at 0, my y value is 3. If I look at my y value at 1, an x of 1, I can see that the y value is 6. So to get from here to here, it's multiplied by 2. I can pretty much guess what it's going to be at 2. I'm assuming it's going to be multiplied by 2 again, and I'm thinking it's 12, but I can double check. If I go to an x value of 2 and I follow it up until I hit my graph, it is 12. So what this means is that since all of these have been multiplied by 2, I am going to have a 2 in my bracket, and that is the equation of this graph. We've gone through a few different examples, and so now it's time to talk about how are these functions the same and how are they different. So I have three functions here, 3 to the x, 10 to the x, and 1/3 to the x. So I know that this first one is increasing. This number is bigger than 1. The exact same thing goes for the second one. This one is also bigger than 1. This number, 1/3 or 0.33, is not bigger than 1, so this is a decreasing function. This is a decreasing graph. So already I see we have two the same, two that are increasing, one that's decreasing. Between the two that are increasing, I have a 3 to the x and a 10 to the x. I know that this one is much steeper because the higher the number, the steeper it is. All right, we're almost done. So this is a great question that I could ask you in the future. I'm giving you a fill in the blank here, and there's multiple answers. So we need to come up with an equation for this first one that is between this least steep and this steepest. So the least steep is 2x, the steepest is 7x. So I need to come up with a graph that is steeper than the 2x, but not as steep as the second x. I'm going to say that g of x, and you could pick any letter you want in here. I just put g because it's f and then g and then h, but it really doesn't matter. So I'm going to say that it's 3 to the power of x. Now, pause the video, think about some other numbers that would work as well. And hopefully you've paused and thought about this, but we could have put 4 to the x, or 5 to the x, or 6 to the x, or anything in between, any decimals or any fractions in between that would fit there. We're going to do the exact same thing for this next one, although now this is talking about y-intercepts. So we know that the y-intercept is the number in front of the brackets. So this one is 0.5. This one doesn't have one, so we have to imagine that there is this imaginary 1 here. So I have to pick a number that is bigger than 0.5, but smaller than 1. Now again, there's an infinite amount of answers. I could pick 0.51, I could pick 0.52, I could pick 0.6. I'm going to pick something right in the exact middle. So halfway between 0.5 and 1 is 0.75. And I should have wrote this a little bit different. And then we could have, I'm going to rewrite this down here. G to the x equals 0.75, and then we could put any function that we want here. I don't care about this base. All I care about is this y-intercept and the fact that it's got to be between 0.5 and 1. Let me just, I can't even erase this now. Sorry. This just ignore. All right, our video is over. What I want you to do is go back to our D2L. I've posted a link to a Jamboard, and you are each going to be graphing one of the equations that's up there. If somebody has already picked a particular equation, just go to the next page and find one that hasn't been done yet. Make sure you put your name on it so that I know who did it.